Hello everyone, thanks for being here. My name is Cyril Colin, I'm the co-founder and CEO of Elum Energy. I'm glad to present today where our vision is really to industrialize a world called monitoring and control of renewable power plants. So it's a bit of I would say, unsexy world, but the idea is really to use the scalability of the software to replace historical monitoring and control technology to reduce plant construction and operational costs. Okay, so I will give you a bit more context first. So the renewable energy market is really booming, but I think you have a lot of presentation today before me, after me, that will, if you're not convinced, achieve to convince you. And here I'm there today to give you a bit more insight and information about why this renewable energy market is booming, and is it really booming, and will it last, you know? So one figure that strikes me a lot is this one. 20 years ago, we installed 1 gigawatt of solar capacity per year, okay? And last year, we reached 1 gigawatt of capacity installed per day. So essentially a factor of close to 400 in scale, okay? So the challenges that you used to have 20 years ago to install a renewable power plant, to operate a renewable power plant, are totally different than the ones you have today. It's the same as with the batteries. We had a speaker before speaking about the batteries. It's the same kind of economies of scale, but solar is a bit more advanced. And as you all know, but it's good to give the figures, renewables have completely reshaped the grid, okay? And here it's really important to note it's really reshaped. It's not reshaping, right? Because solar is the most cost-effective source of energy on Earth today. And as you can see, there's this learning curve, okay? Mostly driven by hardware's economies of scale. So like big factories producing more cost effectively this technology. And you see this curve going down to the one being below, so essentially the one that's the most competitive as of today. And the blue curve that you see is the curve for the batteries, because as you all know, the solar energy is intermittent, so it means that so it means that you produce not at the moment where you consume, because it's based on the weather. And the storage is there to actually make the link between the two. And those two factors are creating a massive opportunity of more than 2 million plants which are going to be built over the next 10 years. Those 2 million plants are only what we call utility scale and commercial and industrial, okay? We don't count all the residential plants that will be installed, of course, because we are only on the C&I and utility market. And as you can see on the curve, over the 4 past years, we've seen a tremendous growth, more than 45% CAGR in annual installed capacity, okay? Which accounts in 2023 for more than 450 gigawatts, okay? Which is, to give you another magnitude, I'm French, so you can guess through my accent, it's 4.5 the capacity of France, okay? Installed in renewable per year. So it's quite big. And the momentum is huge because, okay, I won't give you too much figures, but I quite like figures. Over the past 20 years, we've installed 3 terawatts of solar. Over the next 5 years, we will install the same capacity. So really, we are in deployment part. We are deploying really heavily, and it's seen on this graph. And actually, this for the forecast ones, it's figures taken from Bloomberg, and the analyst always says the funny thing of saying that he's been working in the space for 20 years and he's always being wrong. But what's good about solar, in forecast I mean, but always in the same direction, meaning that they always underestimate the forecast year on year. I mean, it's a 45% CAGR and 15% over the future. So once we know that renewable market is booming, the main question is how to scale this market. Okay, because as you will see, there's a lot of different challenges in installing and operating a renewable power plant. And there's some hurdles that can be overcome, of course, but that need to be overcome through technology to scale. So as the market expands, and you see the market is expanding quite heavily, new challenges coming when you operate a renewable power plant. And why is it so hard to operate a renewable power plant? For various reasons. First, because a renewable power plant, for me, I always like to use the expression, is like Lego, you know? It's like we're buying stuff, different pieces of Lego, and making them together. Except that Legos are made to be worked together and put one on top of each other. Here's a bit different because you have to imagine that it's essentially different pieces of Lego, but from different manufacturers. Like the PV inverters are manufactured from one brand, the battery are manufactured from another brand, the cables, the inverters, the panels, the sensors, all of that comes from different players. And in order to control and to monitor those assets, you need to be able to make them dialogue together, to communicate, collect data, and be able to control those assets. So that's one of the main issues of those sites as of today. So first of all, as I said, the issue to connect the devices one to another, because they are not made to dialogue together. And dialogue also with third-party interfaces, because as you know, there's more and more grid interfaces, there's more and more grid operators that needs to have remote access and remote control over those assets, because intrinsically renewable power plants are instability factor in the grid because it's intermittent capacity. You have to remember that. So essentially you have those two types of challenges, interoperability and different third party, that create issue to connect a renewable power plant. And the second part is once you've been able to dialogue with those different elements, you need to actually be able to control them. And there it's different from one plant to another, because based on the different energy sources that you have, if you just have solar, or if you just have storage, or if you have EV charging station, or a mix of them, the way you will operate the plant will be different. Essentially, the operating philosophy will depend based on the setup of the plant, okay? And then, of course, the other factor of complexity is the fact that the grid is actually connected, the plant is connected to the grid. So it's like to be interfaced with something else, and therefore you need to actually cope with the constraints that the grid impose on you. Okay, because each grid is imposing different constraints on those power plants to be operated. And therefore, with those four challenges, you have a lot of issues to scale and a lot of issues to replicate those power plants, because each power plant essentially is kind of like unique because different device, different interfaces. And so the question is, how do we address this plant operation complexity as of today? And how the market is addressing it today, and what are the main limits of this market. As of today, legacy solutions are giving, I would say, an unscalable response to those challenges, because those two types of challenges I mentioned of connectivity and controllability are answered through what we call engineering. So it means that essentially I was telling you a renewable power plant is unique, okay? We're not able to scale. So the way we will answer it is by doing specific engineering on a site-per-site approach. So it's really not possible to scale. And the consequence of that is, you've seen a couple of slides before, this curve, learning curve of cost on solar. I've told you that it's mostly brought by hardware's economies of scale, okay? And now we've reached a certain stage where more than 50% of the cost to build a power plant, 50% of the capex, is what we call soft cost, not software cost, like human labor cost, okay? So engineering, procurement, construction. So we've reached a stage where the main cost component of a solar asset is not the hardware itself that you buy, it's the human cost behind to install it, to engineer it, and to operate it, okay? So here you understand why building a software technology that automates engineering, automate installation and operation can have a great lever in improving the competitiveness of renewable energy, because you reduce through software those human costs. You spend less time installing the plant, you spend less time operating the plant, so therefore you gain competitiveness and you're able to scale. And so that's where Elum Energy comes into play. Okay, we have created a technology called the Energy OS, Energy Operating System, and the Energy Operating System is, as I said, the main objective is to bring scalability to this renewable world by erasing a bit of this engineering, installation, and operational cost through automation. Okay, so that's why we've built this product suite. It's I have the habits to say that so we are bringing to the software age essentially the automation stage, right? Where you used to use, if you're expert, what we call PLCs, and then you build engineering on top of it to control your renewable power plant. Here we use software, and we automate a lot of tasks that in the past were have to be made on a plant-per-plant approach, okay? And again, I'm used also to say that the Energy OS is like us, is resting on two legs. The left leg is what we call plant controllers, so it's embedded software inside the hardware that is connected to the different equipments of the power plant to control them in real time, okay? And on the other side is what we call ePower Monitor, which is a remote asset management platform for asset managers. So if you take a bit of a step back, the first part, ePower Control, is really used by what we call site engineers, design engineers at the engineering, procurement, and construction companies. So with the goal of reducing those engineering and construction costs I was mentioning prior to that. And ePower Monitor is more for the asset manager, asset owners, for operating better the power plant and reducing the cost to operate a power plant. Okay? So then the question is, through this technology, what is the real impact that we can have? And essentially, I can also say that the impact is really critical for us because when I'm like waking up in the morning, like I wanted to create Elum Energy because I believe that we are at a moment where making sure that we will address climate change is one of our greatest challenge as people right now, and therefore I wanted to be in a space where you could have economically viable technology answering climate change. Okay, so I think that's the best way to address climate change is to having some things that are economically viable. And I take the opportunity also to say that we are supported by a fund from France that Xange that has a session a bit later. We'll be able to tell more about impact investing. So really the question now is to I've described the technology and its ability to monitor and control renewable power plants. The question is how this technology can really disrupt the market and provide easy and cost-effective flexibility to the grid. So as of today, we have around 2,000 sites, 2,000 plants under operation with our technology in more than 50 countries, okay, in the world. The vision is really two information from this slide. First, the scale of the numbers, going from 2,000 to 40,000 in 2028. And second, the words that are used, okay? As of today, we have installed essentially 2,000 controllers on those plants, and we want those plants to become assets for us, okay? So essentially going from a business where we provide controllers and platform to a business where we can enable flexibility, okay? And how and why? Because really quickly, our business model as of today is to sell controllers to install and operate those power plants, sell the platform to operate the power plant. But the real end game is somewhere else. The real end game is, as of today, we're installing and equipping solar, CNI, and utility plants to actually create a really, really large and I would say diverse asset, which will be composed of a lot of different small systems. Because again, I will stop to give you figures, but over the next 5 years, you will install as much CNI capacity as utility capacity. So it means that you will install as much capacity on a lot smaller sites and more numerous sites of solar than on the really big power plants. Okay, so the main challenge is to be able to leverage this distributed flexibility. Because the flexibility on those large utility plants, you know how to value it because there's a lot of aggregators on the market today. So they know how to value it. But the main question is for these distributed assets of like really small CNI site, then the challenge to actually manage this flexibility is quite bigger because you have to pay and you have to install a controller on every site. Because of our system, you have the ability to connect those systems together and actually to control them together, then to be valued by aggregators on the market. So that's really the end game of the company. And I'm there for you if you have any questions. Thank you.